Imagine your computer just realized it made a mistake writing a complex script for your presentation.
Right.
Instead of freezing, popping up a giant red error message and waiting for you to intervene, it just pauses.
Yeah, it takes a breath.
Exactly.
Right.
It reads its own error log, reasons about the logical flaw in the code, rewrites it, and tests it again.
All completely on its own.
Right. It solves the problem autonomously, all while you are in the kitchen grabbing a cup of coffee.
Which is wild to think about.
It is, because for years, we've been told that running proactive, autonomous artificial intelligence like that, well, it requires tapping into massive billion-dollar cloud servers.
Yeah, the whole narrative was you had to rent this capability from tech giants.
But today, we are looking at a briefing document that hands you the blueprint to run it entirely on your own laptop, and for free.
It is a profound shift in the architecture of computing. We are examining the April 2, 2026 release of Google DeepMind's Gemma 4.
Right.
And this release document outlines something that moves us past the era of the cloud-dependent chatbot. It brings us straight into the era of the localized autonomous agent.
So the mission for our deep dive today is to unpack this specific briefing document. We want to figure out if we are truly witnessing the end of vendor lock-in for artificial intelligence.
Yeah, that's the big question.
We are going to look at the actual mechanics of how this technology is escaping the massive server farms and migrating directly onto the devices you use every day.
It's a huge leap.
Okay, let's unpack this. Because the specs listed in this release are, well, they are pretty dense. Lay out the architecture of what Google DeepMind actually dropped here.
Well, we need to look at Gemma 4 not as a single piece of software. It's more like a spectrum of models designed for different physical environments.
Okay.
The document breaks them down by cognitive size.
Yeah.
On the smallest end, we have the E2B and E4B models.
What does the E stand for?
The E essentially designates them for the edge. These are ultra-efficient architectures engineered specifically to run on edge devices.
Meaning like local devices.
Yeah, exactly. Meaning they operate locally on a mobile phone, a smartwatch, or an embedded sensor without needing a persistent internet connection.
So they live natively right on the hardware.
Precisely. Then, as you move up the scale, you hit the midweights. There's a 12B parameter model and a 26B parameter MOE.
And MOE stands for a mixture of experts, right?
Right. And finally, you have the flagship of the release, the massive 31B dense model.
Okay, I want to stop you there and get into the actual mechanics of these terms.
Sure.
Because mixture of experts versus a dense model, and that sounds like deep computer science jargon.
It does sound a bit intimidating.
How do those two architectures actually differ when I am running them on my machine?
Think of a dense model, like the 31B, as an incredibly brilliant general practitioner.
Okay.
Every single time you ask it a question, whether it's about quantum physics or just how to bake a cake, the entire 31 billion parameter neural network activates to process your prompt.
Wow, the whole thing turns on.
Yeah, it uses a tremendous amount of compute, but it applies its full monolithic brain power to every single task.
That sounds exhausting for a computer's memory.
It is incredibly taxing, which is why the MOE, the mixture of experts, is so clever.
How so?
Well, imagine a massive hospital instead of one general doctor. When a patient comes in with a broken arm, you don't call the cardiologist, the neurologist, and the pediatrician into the room.
Right, that would be overkill.
Exactly. You only page the orthopedic surgeon. In a 26B mixture of experts model, the neural network is divided into specialized subnetworks.
Oh, I see.
So when a prompt comes in, a router inside the AI analyzes the request and only activates the specific expert nodes required to answer it.
That makes a lot of sense.
Yeah, it might have 26 billion parameters total, but it only uses a fraction of them for any given task. This drastically saves computational power and speeds up the response time.
That explains how they are packing so much efficiency into these smaller footprints. But the document also highlights a 256K token context window across the board.
Yes, which is massive.
Yeah, just to visualize that for you listening, 256,000 tokens is roughly equivalent to handing the AI a 200-page novel.
Or a massive stack of financial spreadsheets.
Right. And instructing it to keep all of that raw data in its active working memory while you collaborate with it.
And that context window is natively multimodal, too.
Meaning it handles more than just text.
Exactly. The briefing makes it clear you are no longer limited to typing text. You can feed it an image of a complex mechanical blueprint, a 200-page PDF manual, and in some of these models, direct audio streams.
That's incredible.
But what truly anchors this briefing document are the performance benchmarks. At launch, the 31B model totally dominated the open evaluation systems.
Yeah, the document lists Arena AI, MMMU Pro, and GPQA Diamond. Let's decipher those for a second.
Sure, so Arena AI is essentially a blind taste test for models.
Like the Pepsi challenge, but for AI.
Basically, yeah. Humans give prompts to two anonymous models and vote on the better answer. Gemma 4 leads there, but MMMU Pro is far more rigorous.
How does that one work?
It tests multimodal reasoning. It will feed the AI a complex, multi-layered chart from a financial report and ask it to deduce the underlying market trend.
So it's not just reading text, it has to interpret visuals.
Right. The model has to actually see the image and run logical deductions. And then you have GPQA Diamond.
Oh man, I've seen the questions on GPQA Diamond.
Yeah.
They're designed to be absolutely punishing.
They really are. They are questions drafted by PhD-level experts in biology, physics, and chemistry.
Makes sense.
The design philosophy of GPQA Diamond is that even a human with a PhD in an unrelated field should fail the test.
Wow.
And the Gemma 431B dense model excels here, ranking in the top 3 open models globally. It is going toe-to-toe with proprietary models 3 or 4 times its size.
That's impressive.
On a byte-for-byte efficiency scale, it is a champion.
Look, benchmarks are fantastic for scientists in a lab. Bragging about GPQA Diamond scores looks great on a press release.
Yeah.
But I have to push back a bit on the real-world utility here. Knowing the answer to a PhD-level physics question doesn't translate to helping you, the listener, get your actual work done on a Tuesday afternoon.
That's a fair point.
I mean, having a brilliant trivia champion on your laptop is novel, but how does this actually change the way a business operates?
That distinction between knowing and doing is exactly the crux of this April 2026 release.
Okay.
The real breakthrough detailed in the briefing isn't the GPQA score. It's Gemma 4's performance on a benchmark called Tau2 Bench.
Explain how Tau2 Bench differs from the others.
Well, Tau2 Bench doesn't measure trivia or static reasoning. It measures agentic tool use.
Agentic tool use.
Right. It evaluates how effectively an AI can interact with an external digital environment. We are pivoting entirely from what the model knows to what the model can do.
Oh, I see. We're crossing the boundary from passive advice to autonomous action.
Exactly. Gemma 4 is engineered with native support for function calling and agentic workflows.
Break down function calling for us.
When we talk about function calling, we need to understand the mechanism. In older models, if you asked for the weather, it would just guess based on old training data.
Which was usually wrong.
Right. With a function calling, the model is trained to recognize when it lacks information. And instead of generating human text, it generates a precise string of machine code.
Like a script.
Usually a JSON payload. That JSON acts as a digital key that reaches out to a weather API, grabs the live data, pulls it back into its context window, and then answers your question accurately.
I want to use an analogy from the source materials to ground this, because this mechanism changes everything.
Go for it.
If you think about the previous generation of large language models, they were like having a brilliant but completely immobile assistant.
Okay, yeah.
You say, I want to make a complex lasagna for dinner tonight, and the assistant writes out a flawless Michelin star recipe. But you still have to go chop the onions.
You still have to do the work.
Exactly. The cognitive load is on the machine, but the execution load remains on you.
You are still the physical operator of the workflow.
But an agentic model, utilizing this function calling, operates completely differently.
Right.
You say, I want lasagna, and it gives you the recipe. But then it uses a JSON payload to check your smart fridge's inventory API.
Oh, wow.
It sees you are out of ricotta cheese. It generates another payload to interface with your grocery delivery app, authenticates your account, orders the cheese, monitors the delivery status, and notifies you when it arrives.
It handles the whole chain.
Yes. It perceives the environment, reasons about the deficit, takes an action, and learns from the result.
What's fascinating here is how giving this level of execution autonomy to an open model restructures human-computer interaction.
In what way?
We are shifting from being operators of a tool to being managers of a digital workflow. You establish the intent, and the model handles the execution loop.
So it manages itself.
Basically, if it encounters a blocked API, it doesn't wait for your prompt to fix it. It reasons about the error and tries a secondary data source.
So what does this all mean? If this engine can act autonomously, and I can download it onto the localized server, how does that actually shatter the vendor lock-in we talked about at the beginning?
It's all about access.
Because renting access to a cloud-based agent from a tech monopoly still leaves you at their mercy regarding pricing and privacy.
The mechanism that breaks the monopoly is the specific software license Google DeepMind used for this release, which is Apache 2.0.
Why does a legal license matter to the engineering?
Because the phrase open source gets manipulated a lot in the AI space.
That's true.
Many companies release models under restrictive licenses. They say you can use it, but, if your company has over 50 million monthly users, you suddenly owe them massive enterprise fees.
Right, the hidden catch.
Or they explicitly ban you from using their model to train your own internal AI systems.
So it's not really open.
Exactly. But Apache 2.0 is true, unencumbered commercial open source software. You can download the actual weights, the synaptic architecture of the 31 billion parameter reasoning engine.
So you fully own your copy.
Yes. It is legally yours to use, modify, and monetize.
Let's apply that to a highly regulated sector. Say I am a chief technology officer for a multinational healthcare network.
Okay.
I have millions of proprietary patient records. I want an AI agent to analyze this data to find inefficiencies in scheduling and billing. Historically, I could never use a frontier AI for this.
Because sending sensitive health data over the internet to a third-party cloud provider's API violates IPTL laws and internal security protocols.
Huge liability.
The risk of interception or data leakage is catastrophic.
But with Apache 2.0 and the Gemma 4 release,
You take the model, you pull it behind your corporate firewall, and you install it on your internal servers.
safe and secure.
You then fine-tune it directly on your proprietary patient data. The data never leaves your building. And when we factor in the E2B and E4B models, we get what the industry calls the edge advantage.
This is where you run the inference entirely on a local device, not even on an internal server farm.
Imagine a robotics manufacturer. They have a physical robot arm on an assembly line.
Okay, picturing that.
If that robot needs to query a cloud server to recognize a defective part, that round-trip latency might take 200 milliseconds.
Which doesn't sound like a lot.
It doesn't, but on a fast-moving assembly line, a 200 millisecond delay results in a physical crash.
Oh, wow.
By deploying Gemma E2B locally on the robot's onboard chip, you achieve near zero latency.
That's a game changer for manufacturing.
And you also eliminate ongoing cloud inference costs. Every autonomous decision the robot makes is essentially free.
The briefing also points to the broader ecosystem heavily supporting this localized deployment. Platforms like Hugging Face and software libraries like llama.cpp have optimized these models.
Right, making it accessible.
So everyday developers can run them on standard consumer hardware. It isn't theoretical. The infrastructure is highly decentralized right now.
Absolutely.
But let's look at the actual bottom line. Does building this internal private army of AI agents actually translate to corporate returns?
The document provides some striking corporate evidence on that front.
Let's hear it.
It cites enterprise surveys conducted by PwC covering deployments throughout 2025 and early 2026. The metrics indicate that companies successfully integrating these open agentic workflows observed up to a 66% increase in productivity in targeted departments.
Wait, a 66% increase?
Yeah, it's massive.
That isn't a minor efficiency gain. That is fundamentally doing 5 days of complex work in 3 days. Where exactly are they measuring those numbers?
The data isolates specific high-friction administrative tasks. Take an IT service desk, for example.
Okay.
Instead of a chatbot just linking you to a troubleshooting article when you get locked out of a proprietary database, an authorized autonomous agent navigates the backend server, verifies your credentials, and executes the reset command on your behalf.
So it actually does the job.
Exactly. Or look at data analysis. The human sets the parameter. Like, I need to know our quarter-over-quarter churn rate in the European market.
A pretty standard request.
Right. And the agent autonomously writes the SQL query, extracts the raw data from the data lake, runs the statistical analysis, generates the visual charts, and drafts the executive summary.
And what does the human do?
The human only reviews the final product.
This sounds incredibly compelling. You have a highly capable autonomous reasoning engine that you can download for free, legally modify, run securely behind your own firewall, and use to boost departmental productivity by 66%.
It's the dream scenario.
So here's my reality check. If the technology is this frictionless and profitable, Why isn't every single Fortune 500 company deploying a fleet of Gemma 4 agents today?
Well, because we have to separate the elegance of the AI model from the chaotic reality of corporate infrastructure.
Yeah, the messy back end.
Exactly. The briefing document dedicates significant space to this exact friction point, pulling research from Errol and colleagues at the MIT Sloan School of Management.
What does the MIT research reveal about deployment?
The MIT team found that while agentic systems absolutely elevate performance, an astonishing 80% of the effort required to deploy them has nothing to do with training the AI.
Really? 80%?
Yeah. 80% of the friction is rooted in data integration, corporate governance, and wrestling with outdated legacy workflows.
So the AI brain is living in 2026, but the corporate nervous system is stuck in the past.
That's exactly it. Let's look at the hard statistics from the surveys.
Okay.
Between 53% and 62% of companies cite severe security and governance concerns as their primary roadblock.
That makes sense.
It is one thing to let an AI read a database. It is a completely different risk profile to give an autonomous agent the authorization credentials to overwrite data, delete files, or send external emails to clients on behalf of an executive.
I can vividly picture that nightmare scenario for an IT director.
Yeah.
You're trying to get this hyper-advanced, fast-moving agent to communicate with a 25-year-old payroll system without accidentally corrupting the entire employee database.
And that is a common reality. The research highlights that 42% of enterprise implementations require the agent to connect to 8 or more disparate data sources.
That's a lot of tangled wires.
The pipes simply do not connect easily. The APIs are undocumented, the data formats conflict, and the legacy software lacks modern security gateways.
What happens when organizations try to force these systems together by creating multi-agent networks? The document mentions this as a specific vulnerability.
If we connect this to the bigger picture, multi-agent networks are where the risk compounds exponentially.
How so?
A multi-agent system is when you deploy specialized agents to talk to each other. You might have an autonomous supply chain agent negotiating directly with an autonomous financial budgeting agent.
And the inherent risk there is that large language models still hallucinate. They confidently invent facts or drop logical threads.
Precisely. When a single AI makes an error, a human operator typically catches it before taking action. But in a multi-agent system, the machines communicate at network speeds.
Oh, so the error just cascades.
The best way to visualize the danger is a high-speed game of telephone played by overly confident stockbrokers.
That sounds terrifying.
It is. Agent A hallucinated a 0 on an inventory report. Agent B assumes that data is factual, calculates a massive deficit, and urgently requests an order of raw materials.
And then agency just rubber stamps it.
Right. Agent C approves the million-dollar expenditure. The hallucination doesn't just cascade, it amplifies with every step of the autonomous chain.
Which explains why the briefing document vehemently stresses the necessity of the human in the loop.
We simply cannot automate critical judgment. The role of the human shifts to managing the exceptions, setting the strict operational boundaries, and acting as the final safety mechanism before capital or data is moved.
Here's where it gets really interesting to me. The barrier to this revolution isn't technological anymore.
No, it isn't.
Gemma 4 provides the capability. The true barrier is organizational culture. For the last 40 years, we have conditioned the global workforce to treat computers as calculators and search engines. Tools that wait for our command.
Reactive tools.
Right. Now we are demanding that employees become managers of proactive, synthetic coworkers.
It's a huge psychological shift.
You have to learn how to delegate effectively to a machine, how to trust its process, and how to verify its output without micromanaging its internal logic. That requires a fundamental rewiring of corporate structure that moves much slower than a software update.
Building that governance framework, defining exactly what an agent is allowed to execute autonomously versus what requires human authorization, it takes immense planning.
Let's pull all of these threads together to see the whole tapestry.
Okay.
What we are witnessing with the release of Gemma 4 is not an incremental update to a chatbot. It is a foundational toolkit for democratization.
Very well said.
Google DeepMind has taken frontier-level artificial intelligence, the kind of complex tool use and reasoning that previously required massive capital to access, and combined it with an unrestricted Apache 2.0 license.
It changes the game entirely.
We are watching the transition from an era where everyone rents intelligence from a handful of cloud monopolies to an era where you can build your own customized local AI infrastructure.
It is The shift from AI as an expensive external service to AI as an owned internal asset.
As you process all of this, I want you to examine your own daily workflow. Look at the friction points in your week.
Think about the bottlenecks.
Yeah. Where could a localized, private, proactive agent take over the repetitive administration?
The stuff that bogs you down.
If you didn't have to worry about your data being siphoned off to a cloud server because the intelligence lives entirely on your hardware, what complex multi-step tasks would you finally feel comfortable delegating?
It opens up so many possibilities.
But the technology is sitting on the table. The only remaining bottleneck is your willingness to redesign how you operate.
The tools for autonomy are now openly available.
And as we close out this deep dive, I want to leave you with a scenario to explore on your own that moves past the corporate deployments and straight into your personal life.
Oh, this should be good.
We've established that Gemma 4 enables hyper-capable agents to run completely locally and autonomously on your devices.
Right.
Imagine you configure a personal AI on your phone. It has access to your encrypted bank records, your calendar, and your communication style. It is totally private.
Okay, I'm with you.
Now, imagine you notice a billing error from your internet service provider. You simply tell your agent, dispute this charge and give me your refund.
And off it goes.
Exactly. Your private AI agent instantly initiates contact with the internet provider, but it doesn't reach a human customer service representative. It interfaces directly with the provider's corporate AI agent.
Oh, wow. Bot to bot.
You suddenly have two autonomous, highly sophisticated algorithms operating at machine speed, bartering, negotiating, and perhaps aggressively disputing a complex service agreement entirely in the background.
With zero human oversight in the moment.
If those two algorithms reach a binding settlement that violates a corporate policy or accidentally authorizes a payment that drains your account, well, where does the ultimate legal liability fall?
That is a massive legal gray area.
When two locally hosted autonomous machines disagree in the real world, who exactly is responsible for the outcome?
Something to think about.
Keep diving deep.